Hi, today we're going to be talking about cloud service models, deployment models, and security. We'll be covering 5 things. So, cloud service models, cloud deployment models, security issues in the SaaS model, authentication and authorization issues in the SaaS, and of course, the security issues in the IaaS model. So, it's really helpful to watch the first video because I delve deeper into what cloud service models are. But in a sense, it's just like a good example is iCloud or Google Cloud or AWS. Anyways, let's just talk about the cloud service models. So cloud computing, from the last video, it's typically delivered through the 3 main service models. Think of the 3 as layers of responsibility, where you have the amount of control you have and the amount of work the provider does for you changes at each layer. Anyways, infrastructure as a service, or IaaS. This is the most basic or common layer. The provider gives you access to fundamental computing resources, virtual machine storage, and networking. And you're responsible for everything above that: the operating system, middleware, runtime, and your applications. Examples are like the Amazon EC2, Google Compute Engine, or Microsoft Azure virtual machines. It's basically like renting an empty apartment, and you get the walls and the water and the utilities and stuff, and you bring your own furniture, and then you decide how to use the space. And then we have platform as a service. Here, the provider manages the underlying infrastructure and the operating system, runtime environment, and middleware. You basically focus on writing and deploying your application code. Examples are Google App Engine, Microsoft Azure App Service. This is like renting like an Airbnb or like a furnished apartment, and a lot of setup is already done, and you just move in and start. Well, not an Airbnb, more like an actual furnished apartment. Software as a service. This is the highest layer, and this is where the provider manages everything, and the consumer simply uses a fully functional application over the internet, usually through a web browser like Gmail, Salesforce, Dropbox, and Microsoft 360. This is like staying in a hotel. Okay, this is like the staying in a hotel. It's like helpful way to remember the difference. It's really helpful. Like for me, I think of like the housing examples. Like the difference is you move from IaaS to PaaS, and then finally to SaaS. And the provider takes on more responsibility, and the consumer has less to manage, but also less control and customization. And then moving on to cloud deployment models, since we meaning where and how the cloud infrastructure is actually hosted and who has access to it. So the public cloud, in this model, the infrastructure is owned. It is owned and operated by a third-party cloud provider and made available to the general public over the internet. Resources are shared through multiple organizations. It's typically known as multi-tenant environments. This is the most common cost-effective model, like I said earlier, like AWS or Google Cloud public offerings. The trade-off is less control over underlying infrastructure and shared resources with other tenants. And then we have the private cloud. The cloud infrastructure is provisioned for exclusive use by a single organization. It can be hosted on premises or by a third party, but access is restricted to that one organization. The model offers greater control, security, and customization, but typically comes at a higher cost. It's often used by organizations with strict regulatory or compliance requirements like banks or government agencies. And then we have hybrid clouds. This is the combination of the two, which was discussed. For example, private or public cloud that remain separate entities but are bound together by technology that enable data and the application portability. A common use case is keeping sensitive data on a private cloud while using the public cloud for less sensitive workloads or to handle traffic spikes or heterogeneous cloud bursting. And then there's community cloud. It's shared by several organizations that have common concerns such as mission, security requirements, policy, or compliance consideration. It might be managed by the organizations themselves or by a third party. A good example would be cloud shared among several government agencies or universities with similar regulatory needs. Choosing the right deployment model really comes down to balancing the cost, control, security, and the compliance needs. And then, since we covered that, we have to talk about security issues in the SaaS model. Starting with this, it's the model most end users interact with directly because SaaS applications are fully managed by the provider, accessed all over the internet. Several unique security concerns could arise, like data security and privacy. Since data is stored on the provider's servers, often shared across a multi-tenant environment, there's a risk of data leakage or unauthorized access between tenants if isolation isn't properly enforced. Organizations must trust the provider to implement strong encryption, both at rest and transit. Data location and compliance. Consumers often don't know exactly where their data is physically stored, which can create compliance issues, especially with regulations that dictate where certain data must reside. And then there's the multi-tenant risk, because if everyone share the same underlying application infrastructure, a vulnerability in the shared environment could potentially expose one customer's data to another. So this is sometimes called tenant isolation failure. Insecure APIs. This specific model often rely on APIs for integration with other services. If these APIs aren't properly secured, they can become an entry point for attackers. And then lack of visibility and control. Since provider manages the entire stack, consumers have limited visibility into the underlying security models, making it harder to independently verify that proper security measures are in place. And data loss and backup concerns. If a provider experiences an outage, data corruption, or even just out of business, customers may face permanent data loss if proper backup and recovery mechanisms aren't in place. And then there's vendor lock-in. While not strictly a security issue, there's a difficulty of migrating data out of an SaaS platform can leave organizations stuck with the provider even if security concerns arise. Because of these risks, choosing a reputable SaaS provider with strong security certifications and understanding the shared responsibility model is absolutely critical. Cybersecurity, you really have to think about that, especially now that most of the things online, banks and stuff, it's should really concern the normal citizen. It doesn't matter if you're studying computer science or not. With everything becoming digitized, I think cybersecurity is one of the most utmost things people should really learn about. And then again, there's authentication and authorization issues in SaaS. These are closely related, and then verifying who a user is and controlling what they're allowed to do. Weak or inconsistent authentication mechanisms. Many of these applications rely solely on username and password combinations, which are vulnerable to phishing, credential stuffing, and brute force attacks. Multi-factor authentication MFA accounts remain highly exposed. This is really bad. And then identity federation challenges. Large organizations often use multiple SaaS applications, each potentially requiring separate credentials without proper identity federation. Using standards like SAML or OAuth, managing consistent authentication across services becomes difficult, and users often resort to weak or reuse passwords, which is really common, like if like it's really common because it's really annoying to have different passwords for everything. So some people just take the easier route, which is really bad because, again, it's easy for hackers or intruders to just steal your data. And there's single sign-on or SSO risks. Well, SSO improves user convenience by allowing one login to access multiple services. It also creates a single point of failure. If an attacker compromises the SSO credentials, they may gain access to every connected application. And then authorization and access control failures. This addresses what unauthenticated users can actually do. Poorly configured role access based access control or can lead to privilege escalations where users gain access or to data or functions beyond what they should have. This is especially dangerous in a multi-tenant SaaS environment. And then we have session management vulnerabilities, basically just insecure session handling, like the tokens don't expire and then they're not encrypted. And then there's third-party application integration where they allow integration with third-party apps through OAuth tokens. If these permissions are overly broad, disconnected third-party app is compromised and it can create a backdoor into the primary SaaS environment. And then there's insider threats, where the providers manage underlying infrastructures. There are also risks of malicious, negligent insiders at the provider level gaining appropriate access to customer authentication data. To mitigate this, the companies or the organizations should enforce multi-factor authentication, adopt standardized identity federation protocols, and regularly audit access permissions and allow the principle of less privilege when assigning roles. And then we talk about security issues in the IaaS model. So there's shared responsibility confusion. The provider secures the physical infrastructure, data centers, hardware, virtual layer, the boring stuff, and then the consumer is responsible for securing the operating systems, applications, and data. And then there's virtual machine and hypervisor vulnerabilities, and then there's insecure APIs and management interfaces. Data breaches due to misconfiguration, denial of service, or DOS attacks. Then insufficient identity and access management, data persistence issues, compliance and auditing challenges. These are a lot of issues that need to be mitigated. Like, in order to mitigate these risks, it requires strong encryption practices, careful configuration management and network segmentation, robust identity and access management, and regular security audits, combining the provider's infrastructure level protections with the consumer diligence at the applications and data level. Now that's a lot of words. Like, in conclusion, the three cloud service models, IaaS, PaaS, and SaaS, and how the responsibility shifts provider and consumer at each layer. And then we talked about the 4 deployment models, and then we talked about the security and these risks in each of these layers. Like, I think understanding these concepts is really important, especially modern day, because it doesn't matter if you're studying cybersecurity or IT or computer science. I think where the world is moving, we're moving towards a more digital future. I think it's really important to understand how these cloud service models work to mitigate the risks of your data getting leaked. And yeah, it's just really helpful even if you're not studying IT. Yeah, I think that concludes the video for today. Thanks for watching. See you in the next one.